Okay, guys, so here it goes. This is the second part of the video. So number 2, a particle moves along the x-axis so that at any time its velocity is given by that function. Determine all the intervals when the particle is moving to the right. Okay, so when is a particle moving to the right? When velocity is positive. Now, the biggest mistake that people are going to make with a problem like this is they're just going to kind of mindlessly take the derivative because they're going to be used to, oh, something is, the particle's moving to the right when its derivative is positive. But velocity is already the derivative. This is the first derivative already. So you don't need to take the derivative. So you've really got, when you're asked a question like this, you've got to be careful. Are you given velocity or are you given the original function? Because if you're given the original position function, then in order to answer this question, we would need to take the derivative and figure out where it's positive. But this is giving us velocity, so the only thing we've got to do is figure out where this is positive. So the derivative has already been taken. So we're going to find out where this is 0. So this is the part where you're finding what are called the critical numbers. So you just set it equal to 0. I'm going to take out a negative 4t squared. So we get t minus 12, right? Okay. And by the way, guys, I wasn't writing like equals 0 on these, but I don't know. Maybe I should have been. But just know that the critical numbers, the numbers that you find to put on the number line, are where f prime is 0 or undefined. So even though I didn't write equals 0, that's what I was doing. All right. So I hope that's clear. So then, this is a problem where time is greater than or equal to 0. So for this factor right there, you're just going to get 0 as the critical number, which is the endpoint anyway. And then here that's going to give us 12. All right, so I don't know, I'll pick like 1, I'll pick like 15. So I plug 1 in. If you plug 1 in here, you're going to get a negative times a positive. You're going to get a negative, a whole thing that's negative. You plug it in here, you'll get a negative. So that interval is positive. If you plug 15 in here, you're going to get a negative. That negative 4 is always negative. So you're going to get a negative times a positive, which is again a negative. And then you plug 15 in there and you get a positive. So that's negative. So moving right would be the interval, where velocity is positive. So, yeah, so answer, and I'll just write here, this is v of t. This number line is for v of t. So answer is from 0 to 12. Okay, that's the answer. Alrighty, this one. Okay, this is just like number 1, except we're going to use a calculator. You'll love it. So a particle moves along the x-axis, so same situation that we've been dealing with. We're given the velocity. Oh, okay. Actually, it's not the same as the first one. But yeah, it's not the same as the first one exactly, because we needed to take the derivative for the first one, and here we don't need to. But still, this calculator method would work for the first one also. You just would have to take the derivative first. So determine all intervals when the speed of the particle is decreasing. So now we're looking for where the particle is slowing down, which is when velocity and acceleration have opposite signs. Shoot, but, however, guys, if you just know, this is what I wanted to do. If you know that the speed function is equal to the absolute value of the velocity function, then you can just put the speed function in your calculator and look where the graph is decreasing, okay? It's super fast. All right, so you don't want to practice this all the time, you know, because you want to be good, you want to be fluent in the other way, but okay, so I want to do the absolute value of that. So I go math over to abs, 15x squared minus 30. All right, and then I graph. Oh, well, my table, let me make sure that my x is starting at 0. Let's see what it looks like. Okay, I don't really like that window. So let me go to window. And it's an absolute value function, so there's not even any negative part. So let me like go up to 30 or something. Okay. And yeah, so we're looking for where the speed is decreasing. And if you look here, it's decreasing right there. Okay. So, you know, how would you know for sure what that number is up top? Using the calculator, if you wanted to just use the calculator, you would go second trace max. You gotta find the thing. There it is. Okay, so left bound. So you go to the left of the top, and then right bound, you go to the right of the top. Okay, now this, if they're giving you something like 0.99999, that's 1. Okay, if your calculator is giving you something like that, that is just 1. And it looked like it was 1 anyway. But you need to verify it either with algebra on the paper or with your calculator. So the interval is looking like it is starting at 1. And then it looks to me like it's ending at 2. But again, we have to verify that with our with some algebra with some math work on the paper or this. So this would be like a minimum. So you can go second calc again, minimum. Oops. Okay, and again, if it's something like 2.00000, if your calculator is giving you that, it's 2. Yeah, so there it is. And then I'm just gonna like draw a little picture of this for you guys on here, like for your notes, but there you have it. I will talk to you later.